Hi guys, let's go ahead and try and finish up 4-4, which is a monster of a section. We've already done transformations, we've done the symmetry, and then the last bit is the monotonicity. So monotonicity is a fancy way of saying that function gets bigger or smaller or stays the same. So here I've sketched a random function, so it kind of goes up and down and flat and then up again. So monotonicity is about increasing, decreasing, and constant. Now when I say those words, students have an intuition of what it means to be increasing, decreasing, or constant, right? Increasing, decreasing, and constant. Now if I ask you, well, what does it mean to be increasing? You would say, well, you go up, you get bigger, right? So I want to formulate that mathematically. So increasing would mean my function value is getting bigger, right? So as I walk along the left to right, my function goes up or gets bigger. So a function f is increasing on an open interval I if for all points in I, x1 less than x2, so that means as I travel left to right, so smaller things to larger things, so I travel left to right, I want the y value to get bigger. Okay, so as my x values get bigger, my y values get bigger. That's what increasing means. So as x increases, y increases. So that's my English version. For decreasing, so I want the function to get smaller. So as x increases, y, as x increases, y decreases. Now remember, f and y are the same thing. F of x and y are two ways to write the same thing. So as my x gets bigger, x1, x2, x3, my f of x goes down. So this one's bigger. So as x increases, y decreases. And finally, constant. So if you're constant, you don't change. So x1 less than x2 means, so as x increases, y stays the same. All right. So as x increases, y stays the same. And that's the idea behind increasing, decreasing, and constant. So I've told you before, I have the math version and the English version. And here is my math version. If x1 is less than x2, then f of x1 is less than f of x2. My English version is x increase, y increase. Well, we'll come back to that. Decreasing, as x increases, y decreases, and constant, as x increases, y stays the same. Now, I've actually used the words increasing and decreasing and probably even constant in class, but I didn't really make a big deal of it, and I was able to wrap it up in other meanings. So when I see this, I'm traveling left to right. Here my function goes up. Let's actually use some colors. So here the function goes up, and then it goes down, and then it goes up again, and then it's constant, and then it's up, right? So what do the blue lines have in common? What the blue lines have in common is they all have a positive slope. So if you can imagine holding your arm or your hand or your finger or something up against the side of the function, If you have a positive slope, then you're increasing. If you have a negative slope, then you're decreasing. And if you have a slope of 0, you're constant. And if you take calculus, they actually expand on this idea of the slope telling you information about how the function is behaving. But for us, I think it's sufficient to just, imagine how does your arm, is it pointing up or down? That tells you if you're increasing or decreasing. Or if it's flat, it tells you that you would be constant. So I did have a comment on all of these definitions. Increasing on an open interval, decreasing on an open interval, constant on an open interval. So when you do increasing, decreasing, and constant, everything has to be open intervals. So let's go ahead and do an example. So here's my function I've drawn a sketch of. Now this is a little bit different than the type that are in Hawks. I'm also going to do a Hawks example. But first I want to do one that has multiple intervals. So I've drawn this function and I've put in points of what we would call inflection. Don't worry about the terminology. It's just points where it changes from increasing to decreasing and constant. All right, so I want the intervals or interval where the function is increasing, decreasing, or constant. So I'm going to color code everything. I think on the last page I had increasing as blue. I had decreasing as pink. And I had constant as this magenta purple. Okay. So if you actually have multiple colors, you could do this. Since you're doing it on Hawks, maybe that's not as useful. But I'm just thinking about traveling. Do I have a positive or negative slope, positive or negative, positive or negative, positive or negative slope, right? So the other thing is that increasing, decreasing, and constant is only about the x values. I don't care what the y values are because it's a function, so presumably I know how to find the y values. I just care about the x's. Okay, so increasing. Increasing is going to be all my positive slopes. So this first part is actually a negative slope. Even though the function is pointing up here, so it's pointing up, it has negative slope because if I put my left hand along it, my fingers are pointing to towards positive infinity. They're pointing down. Okay, so that's decreasing. The next bit would be increasing. Then I have a little tiny bit here that's decreasing again. And then I have a bit that's constant. Okay, then increasing, decreasing, and increasing, right? Okay, so anything blue is increasing, anything pink is decreasing, anything magenta is constant. Since I only care about x's, I'm just going to list from x equals -5 to x equals -2, this thing is increasing. From x equals -5 to -2, it's increasing. From x equals 1 to 2, it's increasing. From x equals 4 to on and on and on and on, infinity, it's increasing. So these points 4, 1, that means the x value is 4, the y value is 1. Okay, decreasing. We'll come back, well, no, we just did one like it. So this went on forever. So it went up to infinity for the x value. This one's also going forever and ever and ever in the opposite direction. So it would start at negative infinity to negative 5, then negative 2, negative 1, and 2 to 4. Constant, there's just 1. X equals negative 1 to positive 1. Now, because I've got a bunch of intervals, I don't want them to get lost, I'm going to include the union symbol between them. So you only list x values and it has to be open. If I didn't have it open, like say I included negative 5 in my increasing, if I included the endpoints, so I would both be increasing and decreasing at negative 5. Obviously I can't be both at the same, I can't both be getting larger and smaller. So for that reason we don't include the endpoints. So my notes only list x values, intervals must be open. And monotonicity isn't more difficult than that. So in the next video, I'll do a couple of the Hawks ones. They look kind of different from this. This might actually be considered a little bit harder than what's on Hawks. So if you can do this, you should be okay for the Hawks problems.